Hey guys, and welcome back to yet another video. Today we are gonna be doing flag 13 from injured Android application, and without further ado, let's jump right into the video. So if we go to our application on my Android phone and look at the flag 13, it's called RCE. If I click on the flag, this is just an empty screen. We cannot do anything here. We have the hint button, so if we click it twice, first it says find the binary, and then it says permissions matter. So we cannot really do anything in the application, so let's jump into the source code, and I'm gonna try to find the flag 13 activity. If we look through all of these, there isn't really flag 13 activity, but if we scroll a little bit down, we can see this RC activity, and we click on it because the flag was called flag 13 RCE. Right, so now let's try to read a little bit of the source code and try to understand what the application is doing. So first of all, we can see all of the hints that we have received in the application, and it says find the binary and combine and the permissions matter, but also we can see combine output. So this is a hint throughout like the our exploitation path. So we will take a look at this combine output later. The first thing that we see is find the binary, and we actually already know where to look for binaries in the application because we have exploited a previous flag. I don't exactly remember which one was it. It was with the Narnia, something like that, binary, and we had to do something with that binary. So we found that binary in our application source code. So if you want to follow along, you have to decompile the application using APK tool, injured Android, and then release.apk, and then APK tool D to decompile, and then it's already exists. So I'm not going to do that again. I have it already decompiled. So if I navigate to this folder and navigate to assets, because that's where our previous binary was, I don't think it's very well visible because of this coloring. I'm just gonna go to assets. We can see that there are a couple of applications. This menu that we have exploited, I forgot what was it called, but there are two of these Narnia applications executables. There's narnia.arm64 and then .8x86 and _64. So if I ls-la on this folder, we can see that these binaries are executable. So we can assume that they are executable on the Android phone as well. But if they are not executable for you, you will have to do an extra step. Because we have seen that the source code says that permissions matter, we can assume that we are going to need to run our Android with root enabled. I think that in the latest versions of injured Android, it's executable by default, so you don't really have to do this step, and you can run without the rooted emulator or rooted phone. But if it doesn't work for you, then you have to go to your application here and go to the terminal to open the terminal that you can use. I think my terminal is broken here, so I'm just gonna use my Windows terminal. If I click here, Windows, or I will just launch command prompt with root permissions. Come on. Alright, and then if I type in adb root, we are going to enable adb as root. But my emulator that I have running right now doesn't support being run as root, so I'm not going to do that. But what you have to do is run adb root, and then you have to find the binary in the application, and then run chmod +6 on that application to make it executable. And after running adb root, you will have to run adb shell to jump into the application with root permissions. So if you have done that, if you think that your application will not support that, or if you run errors in the future, then you will have to do this step to make that binary executable. But now let's go back to the source code and try to understand what it is actually doing. So after that, after the hints section, we have something else here. We cannot really make sense of that right now. Then if we scroll down, we have some Firebase stuff. I think it's like in most of the flags, so I'm going to ignore it for now. We can see a path/RCE. Maybe we can take a look at that later. Then we have this private void H class. And what we are doing here, it's taking a file list, and it says if there's an error, it's failed to get the file list. It goes to files, so we can so it's taking a file from /files in the application's source code. So if we would go ahead and take a look at the ADB shell, oh, I cannot do that here because it's not running. As I will just go here, ADB shell, and then if I went to /data, I'm not running as root, so it's not going to work. So it's probably going to be under data, probably /data /data again, then /bnac injured Android. I'm not sure how it is typed, and then /files. So if you have errors while running while exploiting this, you should go ahead and go to files and change the application to being executable in the file section. Then if we scroll down even more, it's catching some statements, doing something. It's not really, we cannot really make sense of this right now. But if we scroll even more further, this is not important as well. This code is more interesting because it's getting a new intent. So we can go ahead to and go to Android manifest.xml and try to find that intent that it is getting. So if we would scroll down through the source code, we would find flag 13 and RCE. So we could assume that this activity is the one being executed by the application, and we can confirm that by looking that the Android name is bnac injured Android RCE activity, which is this one right here. So, and the data that is being passed to this activity is flag 13, which is being a scheme, and host is RCE. So immediately it's a file protocol that is going to be flag 13. So if we go here, and I will just try to type it, so /flag, so probably flag 13 like that, and then colon // because it's scheme, and then host is RCE, so RCE, and then we do stuff later. So it's like a URL. If we would go to a website of some sorts, this would be like the HTTP. If you're probably familiar with the website scheme. So the website would be http example.com, right? So HTTP is the scheme, and our scheme here is flag 13. Then we have the colon // and example.com is the URL, and our URL on the application is RC. So we can take a note of that because we are going to need to exploit it later. If we will scroll down a little bit, we can see that on the RC activity, we can see that there are 3 parameters. The first parameter is binary, then the param, and combine. And it is checking if parameter 3 is null, and if it is not null, then it's executing this function. We cannot really tell what this function is doing at the moment, but if it is not being, but if it is null actually, then we are executing this else statement, and we are doing something with files and the file that we have executed previously. So what we will have to do probably is we will have to write our exploit script, not script, but exploit page, and we will have to open it on the browser of our Android emulator. Then we will have to craft the malicious URL that we are going to craft in just a second, and if we open that URL and it is this parameter 3, it's going to execute something that we probably want, so it's going to be probably flag of this application. So let's go to the binary that we have found and try to make sense of what it does. So if we run file against and I'm going to execute the x86_64 because I'm on Linux, I'm not on the Android phone, so I have to execute this binary, this version of binary. So if I run file against this, it's just an 64-bit executable. So if I /narnia x86 like that, it says a parameter is needed. If I would give it a random parameter, it would not return anything. So at this point you have two kind of two ways of doing things. You can open this binary in Ghidra and try to make sense of what it is based on the decompiled source code, or we can think just logically, because binaries have like most of the binaries have the help page on them or something like that, which we can try to see what they are doing. So if I type Narnia x8664-h, it returns nothing. What if I return what if I type --help? Now it returns the list of available commands, and the available commands are test1, rig, test2, potato, and test3. So let's try to run each of these commands. So test1, it says treasure. If we type in rig, it gives us a URL to YouTube, and it's already familiar to me, so I'm not going to open it. If you want, you can open this URL. Let's move on. So let's now type test2. It says underscore and then potato. You found a potato, right? And then test3. It says planet. So based on this output, I can assume that the rig one and the potato one is not really a good output for us that we want to look at, because they are just some random strings that someone put here. I'm not really sure why they are here, but maybe they have some purpose for the application later on that we have not covered yet. But based on the source code, we will have to combine strings, right? So we have three strings that we can combine. So it's treasure underscore planet. So like that, treasure underscore planet, right? So maybe this could be the combined string for the application on this combined parameter. So let's try to actually create a source code for the exploit. The source code being the HTML file that we're going to open in our Android emulator, and try to exploit this like this exploit. And also I forgot to mention that this runtime, it means that the application is running something like as a command, in like a command. So for like a Python would be system.os or something like that to run a command. So this is just the Java way to run commands on the application if you're not familiar with it. Yeah, so let's try to write the exploit for it. So what we want to do is craft a malicious URL that's going to have a scheme of flag 13, then the host of RCE, and then it is going to have two parameters, binary and param. So first we're going to do what we are going to do is craft a exploit for not an exploit, but like a application, like source code for a web page that is going to execute the first two parameters that we have on our application. Not two, but all like 5 parameters. So test1, rig, test2, potato, and test3. And then we're going to create one with combined parameter that's going to run this treasure planet. So let's try to do that. So let me go ahead and go to a Tmax page, and then I will go back a few directories. So I'm in injured Android folder now, and then vim exploit .html not slash, right? And then we will just create some HTML source code. So HTML body, and then we will just create a paragraph here. We're going to actually create 3 paragraphs. So like that, and then not 3 but 5 even, because or 6, because we need all of the 5 parameters, and also the combined parameter, right? So let me just try to do this somehow. I'll just copy it like that, and then paste here, paste here, paste here. We have 5, and now we have 6. Then we will have to create the a tag with href to open a web page, and the scheme we are going to use is, as we remember, it was flag 13 and then colon slash slash, then RCE, and then we're going to pass in the parameters. So first parameter that we have is binary. So binary will be narnia.x86 underscore 64, and then we are going to have another param because we have param here. So the first param was test1, and then we're going to close this a tag, and then let's just name it like first test, like that, and it's correct. So if we will copy this a tag, I'm just gonna select it here like that, and then just paste it in every single one of these paragraph tags. Let's see, like that. And I'm just going to change some of the things that we are required to change. Did I paste it correctly? Yes. This one is a little bit wrong, so let me just correct it like that, and then like that. Okay, so we have the first test, then we are going to have the second test. No, then we have the rig command, right? Rig. Then we have the second test. Then we have the potato command. What is happening here? Let's type in the potato. Then the third test, and then the last but not least is combined command, right? So the first and I have put a % here. We need the and parameter and symbol to make it a valid syntax. So the first one will be the flag 1, then we have to change the second one to be rig. Then the third one will be test 2, then potato, then test 3, like that, and then the combined output that we had over here. So what was it? It was something with planet. Let me run this executable again with test 1, test 2, and then test 3. So treasure underscore planet. I will copy this and then go back to the vim and then paste that treasure planet command here. So this seems good, so I'm just going to end the body tag and then end the HTML tag to make this proper HTML. Save this, and I'm going to create Python 3 server, and it's going to have be running on port 8081, and I'm going to look at my IF config, the IF config. So my IP address is 172.27.167 and 40. So let's go to our Android emulator and see if we understood the source code correctly. let's go to the Chrome tab here. Then let me just try to paste it maybe. Can I paste it like easily somehow? Paste? Yeah, like that. And then 8081 slash exploit.html. Alright, we can see the things that we have added. Can I zoom in a little bit? I'm not really sure if I can, but if I click here, I just went back. So let me just try to execute them one by one. It's not really well visible, but okay, so the first test, let's click on it. It opened the application, which is a good sign, but it didn't really execute anything. So the reason for that is probably because we haven't changed the executable to being able to execute. But for this if statement, we are not actually executing the binary that we have, and it is just doing this query parameter thing. So I can try to maybe load up another emulator, but it will just take a long time. So let me just go them one by one, but it's not doing anything because we haven't actually specified the emulator. But let's try the combine command that we have here, because that's the condition that we have on parameter 3, which has the combine thing. So let me go back to the application and then click on the combine command. It didn't do anything. Let's go and investigate why didn't it do anything. I think I messed up the source code. Let's see. So if I go back like 2 directories, vim exploit. So yeah, I messed up the combine because it isn't with the binary and parameter. It has to have the question mark and combined, and then equals treasure. Is it combine or combine? Let's see in the source code. It's combine. So let's try to access it again. Let's quit this and go back to the application. Reload the page. Click on the combine command. And it says, congratulations, you have found the flag because we have successfully exploited the RCE activity. So if you wanted to, you can go ahead and change the source code to work for the command for the commands, because you are going to need to have that executable binary here. And what this like little challenge says for us is that we can find some applications in source code of Android applications, and like binary is different, and we can examine those binaries. And if we find something like a bad input or whatever that we can exploit, we can try to gain remote code execution on the application by doing stuff like here, by examining the source code and trying to make sense of how to execute that binary. And if you manage, you can get remote code execution on the application, and it's like you can get paid a lot of money if you're doing bug bounty and stuff like that. So that's it for this little demo video. I hope you learned something, and I will just see you in the next video. Bye.